Hello. Today we are going to be discussing phase changes and temperature. So, quick review from our last lesson. We know that there are three states of matter, and if you do not remember about the particle behavior of those three states of matter, you should go back and review that. So, one thing that we need to know before we move on to the rest of our lesson is what thermal energy is. So, thermal energy is the type of energy associated with heat. How we can know a substance's thermal energy is by measuring its temperature. Substances that are at a higher temperature have greater thermal energy, and substances that are at a lower temperature have less thermal energy. So keep that in mind as we go through the rest of our lesson. So we learned about the different states of matter or the different phases of matter. Today we're going to talk about phase changes. So first we should know that all matter can exist in any of the three states of matter. So what that means is that a substance does not exist only in one state of matter or only in two. It can exist in all three. However, matter can also transition from one stage of matter to another. It can go from solid to liquid, liquid to solid. We're going to talk about that now. What we call that is a phase change. When matter transitions from one state to another, from one phase to another, we call it a phase change. Now, the state of matter that a substance is in depends on two factors. It depends on the temperature of the substance and the pressure that the substance is under. Today, we are going to talk about how temperature affects the state of matter that substances are in. So as a quick rule, we are going to talk about a lot of different phase changes today, and there's going to be a lot of information thrown at you. However, there is one general rule that you should keep in mind, and the rest is simply following a pattern. So as we start to look at phase changes, what I want you to remember is that by increasing the temperature of a substance, I will begin to increase the particle's motion, the particle's spacing, and the particle's kinetic energy. If you keep that pattern in mind, all you have to do is follow that pattern to recall the changes that take place in each of our individual phase changes that we will discuss. So the first phase change we're going to talk about is melting. Everyone knows what melting is. Today we're just going to talk in detail about the behavior of the particles when this phase change occurs. So we know that melting is the transition from the solid state to the liquid state. Melting takes place when there is an increase in thermal energy of the substance. That simply happens by adding heat to the substance. When thermal energy is added to a substance, think back to my rule, we know that the particle speed increases, the particle spacing increases, and the particle kinetic energy increases, hence going from a solid to a liquid. It is important to note that the temperature at which melting begins to occur is called a substance's melting point. So if we look here, we will see that going from the solid state to the liquid state happens through the addition of heat or the addition of thermal energy. And you can see here in the visual that my particle speed increases, my particle spacing increases, and hence my particle kinetic energy also increases. Next phase change that we will discuss is evaporation. Evaporation is the transition from a liquid state into the gaseous state. So we think again about our pattern of increasing thermal energy. We know that evaporation will occur when there is an increase in thermal energy or heat being added to the substance. When this occurs, we know that the particles in the liquid will experience an increase in particle speed, an increase in particle spacing, an increase in particle kinetic energy, and will eventually transition into the gaseous state. If we look again at our visual, we know that starting from the liquid, evaporation will occur when thermal energy is increased or heat is added to the substance. We see that the substance's particle spacing will increase, its speed will increase, and its particle kinetic energy will also increase. Next, we will discuss condensation. Condensation is the phase change from the gaseous state into the liquid state. Evaporation occurs when there is a decrease in thermal energy, meaning that heat is being removed from the substance, or in layman's terms, the substance is being cooled. In this case, that will mean a decrease in particle speed, a decrease in particle spacing, and a decrease in particle kinetic energy. So now you can see on the flip side, when increasing thermal energy causes an increase in many of those factors, decreasing or removing thermal energy causes that particle speed, spacing, and kinetic energy to then decrease. Looking again at our diagram, we know that starting from the gaseous phase, removing thermal energy or cooling the substance will take us down back to our liquid state. We will see that again, that spacing is decreasing. They're coming back together. That speed will be decreasing, and those particles' kinetic energy will be decreasing as well. Next, we have freezing. Freezing is the transition from the liquid state into the solid state. Again, freezing occurs when there is a decrease in thermal energy or a removal of heat from the substance. Likewise, we will see a decrease in particle speed, we will see a decrease in particle spacing, and we will see a decrease in particle kinetic energy. Put a star next to this one because you will be doing a lab very soon. The freezing point is the temperature at which a substance starts to freeze. So once a substance hits that point called freezing point, it will begin to transition from the liquid to the solid state. We see here, once again, going from liquid, removing thermal energy, going to a solid, particle spacing decreasing, particle speed decreasing, and particle kinetic energy decreasing as well. Now we have two additional phase changes, which are extensions from your standard. You do not need to know these, but if you're looking for a 4, these might be something to keep in the back of your mind. Sublimation is the transition directly from the solid state to the gaseous state. So to think of it simply, it skips the liquid state. It never transitions through the liquid state. This will occur when there's an increase in thermal energy, and only very specific substances with certain properties will undergo sublimation. So we don't often see this taking place, something going directly from solid to gas, but it does take place with some substances. Similarly, we have deposition. Deposition is the transition directly from the gaseous state into the solid state, once again skipping that liquid state. Deposition is what takes place when there is now a decrease in thermal energy. The same trends of particle speed, spacing, and kinetic energy will be true for a decrease in thermal energy. And once again, just like sublimation, there are only certain substances under very specific conditions where we will actually see deposition taking place.